So before starting today's video, let me quickly give you a scenario. So I place you a few pencils, a few erasers, a few sharpeners and a few chocolates. I want you to give me the count of the pencils, the sharpeners, the erasers and the chocolates present in front of you. How do you count those? Let me put it in another way. How do you count the number of pencils present in front of you? How do you count the number of chocolates present in front of you? Can you count zero or can you count an empty space? Is it possible to count zero? So in order to get all these questions answered, let's jump right into today's video without any further ado. Hi, I'm Deepthi. Welcome back to my channel Trick or Treat with Mathematics. So, as I told you in my introduction, today we'll be dealing with whole numbers. Before jumping to whole numbers, let me just quickly give you a brief background about natural numbers and a few properties to know before we jump on to whole numbers and understand the difference between natural numbers and whole numbers. So let's start with natural numbers. So what are natural numbers? So I asked you a quick question in my introduction, that is, will you be able to count the number of pencils, erasers, sharpeners and chocolates present in front of you? That was my question to you. And I would expect that answer would be yes, for sure, because we know numbers. So if I say there are 5 erasers in front of me, how did I reach to the number 5? Can I do this? Can I count these as 1, 2, 3, 4, 5? So there are 5 erasers in front of me. In the same way, I can count the number of chocolates present, the number of pencils present, or for that matter, number of anything present in front of you. Because you know how to count using numbers. So these are nothing but counting numbers. So we can call these numbers as natural numbers. That is, natural numbers are nothing but the numbers that start from 1 and there is no end to these natural numbers and they can go on until infinity. But we'll say for now we use the term that there is no largest natural number. What are natural numbers? Natural numbers can be denoted in the form of capital N. Capital N means natural numbers. So all the counting numbers that we have seen before are nothing but natural numbers and they can be denoted by capital N. So how do we write natural numbers? Natural numbers are nothing but the numbers starting from 1, 2, 3 and so on till the largest natural number. Please bear in mind, there is no largest natural number. We only term it as infinity. That is just to represent that there is no end to the number system. Okay, let me make this very clear for you. N is nothing but 1, 2, 3, 4, 5 and so on up to infinity. We write this as infinity. That is infinitely more numbers in the number system. Okay, there are infinite numbers and 1 is nothing but the smallest natural number. So natural numbers, they start from 1 and they end at infinity, or you can say there is no end to the natural numbers. So this is how you write the set of natural numbers. What is a set? Set is nothing but collection of elements. So whenever people ask you or someone asks you to write the set of natural numbers, you will write n and you will write, open the flower brackets and write all the natural numbers in between. I can just stop and then put some dots because we do not know how many natural numbers are, and it is physically not possible to term all the natural numbers in between the flower brackets. Okay. Now let's quickly see the properties of natural numbers. There are no properties, it's a fancy term. It's nothing but what is there in front of your screen. Every property is self-explanatory. For example, let's see. What is 1? Is there any preceding number before 1? No. Natural numbers, they start with 1. Right? So that means, can we write as 1 as smallest natural number? Yes, because they start with 1. So 1 is nothing but the smallest natural number. Okay. Now, next number is 2. How do you write 2? How do you write 2? Can I write 2 as 1 plus 1? Right. See the trend here. 1 plus 1 is 2. Right? How do you write 3? Can I write 3 as 2 plus 1? Let's say brackets from here. Right? So 2 plus 1 is equal to 3. How do you write 4? Can I write 4 as 3 plus 1? So 3 plus 1 is equal to 4, and so on. What do you see in this trend? You will see that the next number in the set of natural numbers can be obtained by adding 1 to the previous number. In this case, 2 can be obtained by adding 1 to the previous number 1. 3 can be obtained by adding 1 to the previous number 2. 4 can be obtained by adding 1 to the previous number 3, and so on. So this is how you get the next natural number by adding 1 to the previous number. But you might have one question. What is the previous number of 1 in order to get the result as 1? What should we add plus 1 to? That is where your 0 comes into picture. 0 plus 1 will give you 1, but there is a catch here. 0 is not a natural number. 0, you can't count 0. 0 is a whole number. 0 means empty. 0 means absence, right? We will deal in depth on the importance of 0, but for now, in natural numbers, there exists no 0. That is the reason we need another number system wherein 0 exists and it represents the completeness of the numbers from 1 or infinity and so on, right? That is where whole numbers come into picture. Now let's see quickly the importance of 0 and what are whole numbers. Now before we go on to whole numbers, let's try to understand what is 0 exactly. What is the importance of 0? Okay, I remember I asked you a question in the beginning of a video. I've told you, can you count 0? I've also asked you, can you count empty space? Right? Now let me give you a quick scenario. So it's your birthday. Okay, for example, it's your birthday and you have friends coming over. And how many friends you invited? Let's say you invited 10 friends. And you have how many chocolates with you? You have exactly 10 chocolates. And you want to distribute chocolates to your 10 friends. Right? So what will you do? You make them sit in one place and you give all 10 chocolates to your friends. Right? So how many chocolates are you left with? Think about it. You'll be left with none. You'll be left with 0 chocolates. You'll be left with no chocolates. If you have a tray that is carrying chocolates, then the tray will be empty. There will be completely absent. There will be none. All these are nothing but they denote 0. That is, 0 is the absence of quantity. You don't have enough, or else you can say it's nullified completely, it's cancelled out completely. That is nothing but 0. That is the importance of 0 also. It allows you to know that okay, fine, my tray is empty, I should go and I should fill it. And you indicate that emptiness using 0. Right? So that is the importance of 0. 0 tends to form an essential place in the number system. Okay? Now the number system that includes 0 is nothing but whole numbers. We will see in depth. However, I would like to quickly catch up on what else and where else is 0 important, so that you will never discount a 0 anywhere you see so. Right. For example, what is this number? 52? Now, what is this number? 502? How do you differentiate this number from this number? What did you do to differentiate? What is the difference? The 0 is the difference, right? You have 0 in between and you have no 0 in between. So, what do you understand? 0 in the entire place value of the number systems, it is a placeholder that differentiates one number from other number. So in some countries it's read as 502, but again it's not equal to 52, it is 502, right? And how many zeros are there here? 1 here, 2, and what is the value of 100? Is it greater than 10? Yes. How did it become greater than 10? By adding this 0. So that is how you use 0 to differentiate from one number to other number. You can find the difference between two numbers if they are placed right in front of you by seeing a 0. Right? So this is how you can use 0, and also it's one of the important points to know about a 0. Right? Now, I would like to touch up on the concept of additive identity. It is also based on 0. So I thought I'll just give you a gist and we can see that furthermore in our discussions later. Additive identity. What is additive identity? 0 can be termed as additive identity. 1 is multiplicative identity. How? What exactly this means? Suppose I'll add 1. I'll just write 1. I'll add 0 to 1. What is the number that you get? 1. 2. 0. What is the number that you get? 2. Right. 10,000 plus 0. What is the number that you get? 10,000. How? Because you are adding 0. That means if you add 0 to any number, it will not change the value of this number. It will keep the value of this number intact. That is nothing but additive identity. So adding 0 to a number will retain the value, the original value of that number. Right? So this is one of the important properties. Now let's see one more last topic under the importance of 0. We'll see this in depth also in the video. Now, what is this? This is a number line. We'll see how to draw a number line. However, in this number line, 0 is right placed in between, in middle of the number line, just to differentiate and or separate the negative numbers from the positive numbers. So, in the number line, any numbers that are written towards the right side of 0 are all positive numbers. Any numbers that are written towards the left side of 0 are all negative numbers. Right? So that is how 0 is used to differentiate between positive and negative numbers on the number line. So this is a quick recap, or you might have already known this, but this is a quick summary on the importance of 0. Now let's quickly jump right into the whole number. Now that we have seen what is the importance of 0, now let's quickly jump into the concept of whole numbers, right? So I told you natural numbers are nothing but n is equal to 1, 2, 3, 4 and so on, right? And there is no largest natural number. What are whole numbers? Whole numbers can be denoted by W, capital W, and whole numbers are nothing but the natural numbers with 0. Okay, so the difference between whole and natural, if you see, is this value 0. So whole numbers are nothing but a set of elements or a set of numbers that start from 0 and they will go on infinitely, right? So the smallest whole number is 0, but there is no largest whole numbers, as we have seen with the case of natural numbers. Okay, so this is how you differentiate a natural number and a whole number by an addition of 0. So this will go on infinitely. Okay, so this is a very brief introduction of whole numbers. I've tried to set the tone for you by going in depth on how whole numbers came into picture and the importance of 0 and how we count numbers using natural numbers. So in the next video, we'll see the number line and the predecessor and successor of numbers. We can determine this using the number line, or we can determine this just by the concept. If you are new to my channel, hi, I'm Deepthi. Welcome to Trick or Treat with Mathematics, and if you like my videos, I hope you like, share and subscribe to my channel and hit the bell notification down below so that you would never miss an update from me. Till then, have a safe day and a wonderful week ahead, and the puzzle of the day will be following you along with the solution of the previous puzzle. Take care. Bye.